So let's get started. I'm going to talk about the issue of strategy, onto maps, and then patterns, and then we'll get onto the research. So for those of you who don't know where mapping started, it started in this company, for Tango, online photo service, back in 2005. It was a very profitable company, revenue growing, but it had a problem. That problem was the CEO. The CEO was completely clueless, making stuff up as they went along. And I know this because I was the CEO. I used to read everything I could find about strategy books. I was getting absolutely nowhere. Any strategy I was coming up with just random words mixed together. And then I ended up in a bookshop in London. And the bookseller asked me, had I ever read Sun Tzu's The Art of War? And I hadn't. So she persuaded me to buy two different versions of the book because they're all translations. And I'm very grateful because it was in the reading of the second version I noticed a particular pattern. So Sun Tzu talked about 5 factors that mattered in competition. Have a purpose, a moral imperative. 2, understand your landscape that you're competing in. 3, understand the heavens, the climatic patterns, so how the landscape is changing. Then understand doctrine, principles of organization, and then you're into leadership and gameplay. And I like this because it overlapped with something the Mad Major John Boyd had created called the OODA loop. So the first, the first O of the OODA loop is to observe the environment. That's what landscape and climatic patterns are about. So the landscape and how it's changing. Then you orientate yourself around this space. That's what principle is about. Then you decide where to act, and then you act. And of course, when you act, it changes the game. And so it's a cycle, keeps on going. And at the heart of this are 2 whys. The why of purpose, my moral imperative to do something, and the why of movement. And the best way of understanding that is through a game of chess. So your why of purpose might be to win the game. It might not be. You might be wanting just to lose the game or just to have some fun. Your why of movement might be, do I move this piece or that piece? And it's through movement and action that we actually learn how to play the game as long as we can perceive the environment. And this is why landscapes are so important. So important in terms of military history and so many different other spaces as well. And that's what got me into maps. So back in 2005, the first thing I did, well, it was 2004, 2005, roughly that sort of boundary. I asked everybody in the company, give me your maps. And I was sent loads of maps, mind maps, business process maps, almost like a prototype customer journey maps, all these sorts of things, systems maps. And I took one of them, and this is the online photo service, and I looked at one component. It's a simplified version, customer relationship management, and I simply moved it on the map. And I asked, how has that changed? And the answer is, it hasn't. And well, that's odd, because if I take a geographic map and I say take Germany and put it next to the UK, that's definitely changed. So why hasn't this changed? Well, it hasn't changed because it's not a map, it's a graph. And that's the first thing to understand, that almost everything we have in business that calls itself a map is in fact a graph. So these 3 images at the top, they're all graphs and they're identically the same. 3 places, Nottingham, London, Dover, connected by 2 roads, M1, M2. These 3 images at the bottom are all maps and they're completely different. Now, the difference between a map and a graph is that in a map, space has meaning, where obviously in a graph it doesn't. And that concept of space having meaning is really important when you're exploring a landscape. So that's the first thing to remember. Graphs are not the same as maps. Maps are a subset of graphs. All maps are, in fact, graphs, but not all graphs are maps. And almost everything you'll meet in business which calls itself a map is, in fact, a graph. So I set out to create a map of the competitive landscape that I was in. And in order to do so, I needed 3 basic characteristics. I needed some sort of anchor, magnetic north. I need position of pieces relative to the anchor. And then I need what's called consistency of movement. So we're going north, we're going south, we're going east, we're going west. So by that, I mean, if we're going north, we're actually going north. We're not going south. And I started off with my business, but I often use this example. I'm going to use this a bit later, the tea shop, to show you these concepts. So what you've got is an anchor, the public and business. So the public wants cups of tea and the business hopefully sells cups of tea. It's a tea shop. That cup of tea has needs. It needs tea, it needs a cup, it needs hot water needs a kettle, needs cold water, kettle needs power. So what I've now got is anchor at the top and position described through a chain of needs. And we use this concept of visibility. So the further you go down the chain, the less visible you are to the things at the top. Now that gives me anchor and position, but it doesn't give me movement. And it turns out all these forms, components are forms of capital. And there are many forms: activities, practices, data, knowledge, and they all evolve through common stages. Now, technically, we should go stage 1, 2, 3, and 4, because that's what the work back in 2005, 6, 7 demonstrated. But that's fairly meaningless, so we use labels. And the labels, which came out of a huge body of text analysis, is for physical activities, is Genesis, custom, product, and commodity. So by simply asking, here's the anchor, here's the components, how evolved are those components? Now we've created a map. And if I move anything on this map, it changes the fundamental meaning of the map, because what I'm doing is exploring a landscape of space. What I'm also doing is exposing my assumptions and allowing other people to challenge what I'm thinking. And this is really, really important. And to explain why, I'll give you an example. This is an insurance company, 2011. This is their process flow. Need compute, order server goes into goods in, they modify, mount, and rack it. They had a bottleneck around modification of the servers and mounting them. So they came up with a plan to use robotics. They spent 6 months working on this, return investment calculations, all that sort of stuff, ready to go. And somebody asked me to come in and just have a look. Now, the problem is they've generated and built a narrative, a story. And we have an entire industry which tells everybody that to be a great leader, you've got to be a great storyteller. So when you challenge somebody's story, you're actually saying you're not a great leader. And that's why it gets quite, can be a lot of conflict. So I can't go in there and say, why are you using robots? Because it's like, well, we spent 6 months. Who's this person? We've got all these wonderful ROI calculations. So I said, could we map it? And it was like, don't know about that. But 15 minutes later, they created a map. Now, what I can do with a map is I'm now going to challenge the assumptions on the map. So I'm not challenging the person and their story. I'm going to use the map to do it. So they went, user needs compute, order server goods in. They put most of this in commodities. Compute was product for some reason back in 2010, 11. But then they went rack custom built. And I said, well, why have you got rack and custom built? And they went, well, we have custom built racks. So what are the modifications you're making to servers? Well, they don't fit our racks. So we have to take cases off, drill new holes, add new plates to get them to fit our racks. And that's why you need robotics, yes. And of course, somebody in the room just went, hang on, why aren't we using standard racks? And this is probably the most common problem I see in business, people optimizing process flow, when in fact they need to consider revolutionary flow. They're not daft, it's just they're trapped by past history. At some point, custom-built racks made sense. But now they're a commodity, you shouldn't do that. You should use standard racks. You don't need to modify servers. And of course, compute really is a utility, so you shouldn't even bother with that. That should be using something like Amazon. But what we were able to do, literally within 15, 20 minutes, is challenge the entire assumptions of the story in a way which, without conflict, which saved this company absolute millions. And we did a lot of this stuff within government, UK government. This is Liam Maxwell. One project alone, we saved about 425 million by mapping it out. More modern things are things like NASA, Planet working together on their carbon mapper satellite. That project in the background, they were using Woodley maps to coordinate between them. Right, another example I often use, and apologies if you've seen this one before, but it's worth repeating. There's a couple of good stories. A couple of really good points or patterns in this is HS2, high-speed rail. So big, heavy engineering project, James Finley, CIO, they needed to build the entire railway in a virtual world because it's cheaper to dig up a virtual world and go, whoops, we've got that wrong, than it is the English countryside. So this is the systems graph, it's not a map, of building HS2 in a virtual world. And James's problem was this: how do I manage it? So this was about 2012. Typically in government, we would just outsource the whole lot and then sort of break it into sort of small, sensible contracts based upon things sounding familiar, like lot one engineering, we'll stick engineering stuff in there. Lot two user experience, we'll stick things about user experience in that contract. But these projects had enormous problems, cost overruns and everything else. So James sat down and quickly mapped it out. This was a Sunday afternoon. He took that systems graph, mapped it out, sent it to me, and asked me, how do you manage this? Now, remember, I started mapping in 2005. So by 2006, 2007, I'd come across this problem. And it was fairly easy to solve, because what we learned was that everything evolves across your map. And as it does, its characteristics change. And because of that, it moves from an uncharted space, where basically things like extreme programming, agile, in-house development work very well. And then the same activity, as it evolves, eventually ends up in a more industrialized space, where you're all focused on reducing deviation. Six Sigma outsourcing works well. So on one side, you're all about reducing the cost of change, because change is the norm. And the other, you're about reducing deviation. And in the middle, Scrum, MVP, Lean, it's all about learning and reducing waste. So very simply, you just apply that to a map. The stuff on the left, you build in-house. The stuff in the middle, off-the-shelf products. Or if you're going to build, use Lean. Stuff on the right-hand side, outsource where possible. If you're going to build, use things like Six Sigma. And this project ended up in front of the Public Accounts Committee because it delivered way ahead of schedule, way under budget, by using appropriate methods. Now, typically, people did the outsource, let's bundle it into small contracts. So let's take one of those contracts, lot one engineering. Let's look at it in mapping format. I can tell you this contract is going to fail even before we've signed it. And the reason for this is that some parts can be defined, efficiently treated, so it can be specified in the contract, but the bits on the left will obviously change. There's no way we can specify them, so we're always going to incur excessive change control cost, and that's just normal. So that's one of the patterns, and there are many patterns we learn from mapping. And just to demonstrate it for those unfamiliar, just how easy this is, I'm going to use an Elvish self-driving car. And what I mean by that is I've taken the systems graph for a self-driving car and translated it into Elvish. And now I'm going to ask you a typical business question. Component A, should we outsource or build our own? Component B, should we outsource or build our own? Anybody got any suggestions? Please put them in the chat. Do you think we should outsource or build our own A? Build our own. Yeah, you build. Okay, everybody's going build their own. X in Elvish. Well, the problem is we have no idea, no clue. So I take the same systems diagram and we'll turn it into a map. And now I'll ask that question again. Should we build our own A or B? We'll start with A. I can see a lot of, okay, you've already gone, let's start outsourcing. Great. It's as simple as that. You've already learned that pattern. Now, one of the things I do have to remind people, because this is becoming a very common problem at the moment, get lots of CIOs going, oh, we've started these big agile transformation projects. Oh my God, it's a disaster. I don't know if people have read what's gone on with people like ANZ as well. There is a world of difference between using agile and being agile. So from a mapping perspective, using agile is where we use things like extreme programming. Being agile is using appropriate methods. So using agile is you use extreme programming when you're building novel and new, but of course you'll use Six Sigma or your outsource for commodity components. You do not want to use agile in that space as well. Of course, if you can't see the map, if all you've got is a systems graph, then you'll do the typical let's outsource it all, let's agile everywhere, etc. So it's very simple. Once you map it, it becomes much easier to identify what you should use. And of course, remember, all of these components are evolving. They're moving from left to right. So that brings us into patterns. Now, the way we learn patterns is very simply, we do pre-mortem challenge with a map. Before we start something, we map it out and we challenge each other. Why are we custom building racks? Why are we custom building kettles, etc.? Then we create the map and then we look at how things are going to change. Then we work out what we're going to do. Then we go do it. And then we do post-mortem learning using the map. So we come back to the map and went, what happened? What changed? Because often in that process is where we learn patterns. It's a bit like playing chess. You know, you record the moves and you go back and you look at the game and thought, oh, we could have done that differently. And there's a whole bunch of patterns. And because this is about anticipation, I'm going to focus on climatic. And so very simply, I'll use a map to explain some of the basic ones. User needs an application built on best coding practice, on a runtime operating system, best architectural practice, compute as a product. The first pattern you learn is everything evolves if there is competition. If there's supply and demand competition, it shifts from left to right. Second pattern you learn is that past success breeds inertia. So if we've got a large installation of a product based of whatever it is, with architectural practices or practices built around it, we're going to have resistance to that change. We're seeing the same with the shift of space from physical to virtual. Virtual is just represents, utility space. If I want an office, I can have 1,000 offices on an API call. And of course, we built a whole bunch of practices around inclusion, around, socialization, collaboration, innovation, all based upon physical spaces, and we've got to reinvent those for the more virtual world. And of course, we have inertia to that because of our pre-existing assets, our offices, our existing practices. As I mentioned, as things evolve, practices change, so you get what's called a co-evolution. So with compute, we got things which eventually became DevOps. So rather than all being based upon what's known as high mean time to recovery, i.e. weeks to get a new machine, so you do N+1 capacity planning, we've got low mean time to recovery, seconds to get a new machine, so we're all distributed systems, designed for failure, continuous deployment, and eventually they got the term Andy and Patrick called it DevOps. Next pattern you learn is componentization. Efficiency of one underlying component enables us to build higher order systems more quickly. Those higher order systems are in what we call an adjacent unexplored space. We don't know what they're going to be. They're uncharted, but we can build them more quickly. So you saw this with cloud. You can build lots of novel and new things. Out of those higher order systems, some of them will have create new sources of value and worth. A bit of a gamble in that space. You don't know what's going to work, but something's going to appear in that space. Now, those are powerful forces: efficiency, speed, new value. So efficiency from it becoming more of a utility, speed of building higher order systems, componentization, new sources of value, the adjacent unexplored. If you're competing against others, you've evolved, they haven't, you create pressure on them to adapt. As more adapt, eventually you discover you have no choice over evolution, which is why if you go back to 2007, we're telling people to 2006, 2007, 2008, it was obviously clear that people had no choice over cloud. You get all these people saying, oh, it's just for startups and blah. It's not a question of if, it's only a question of when. That's it. Of course, that can take quite some time. The last company I know personally who had a punch card system was only 6 years ago. So sometimes technology hangs around for a long time. All right. So we use these maps, or I used them in 2008 for, I used to run strategy for a company called Canonical. They provide something called Ubuntu. We use the maps to identify where to invest, where to focus. So in 2008, we knew it's going to cloud. There's going to be a new emerging practice. Didn't know it was called DevOps. There are going to be new needs. That's where we focused. And also where not to invest. Don't focus on improving best architectural practice for compute as a product. That's behind an inertia barrier. That's going to disappear. This is where to invest. This is where not to go. So it cost us $500,000. It took us 18 months. We were 3% the operating system market against Microsoft and Red Hat. By 2010, we took 70% of all cloud. So if you were in cloud, then you may have noticed that Ubuntu came from nowhere, dominated. Well, you were mapped. All right. Of course, it doesn't stop. Emerging practice evolved, eventually got a name DevOps, Andy and Patrick, and then runtime shifted to a utility. So we got serverless, and that enabled exactly the same effects. We get a co-evolution of practice, eventually got a name. It was called FinOps, new needs being met, and existing applications being built. And the point about this is strategy is iterative. So in 2010, yeah, absolutely, you wanted to be, in 2008 to 2010, focused on cloud and DevOps as it became. By the time you get to 2018, 10 years later, certainly by 2020, your focus should be on using serverless. So these are environments like Lambda, and also the emerging practice FinOps. So all the stuff below it, all the containers, Kubernetes, all that sort of stuff, that's the new legacy. That's not where you want to focus. If you do, you could spend 7 years, getting rid of your old data centers, converting to that environment. You'll just have built the new legacy. Okay. If you're interested in this sort of stuff, there's a wonderful book, The Flywheel Effect, coming up by Dave Anderson, Mark McCann, Michael O'Reilly. Well worth reading. I think it's being launched in November. They were a big insurance company, went down their serverless journey. You'll see lots of maps in there. There's a plug. All right. Climatic patterns, there are a number of those. Then we get into universally useful principles, doctrine. I'm not going to go through that. And then we get into leadership gameplay. And there's about well over 100 different patterns. I'm not going to go through those except for mentioning one. A very simple model called ILC. You take a product and you turn it into a utility. Everybody builds on top from componentization effects. Because you're providing it as a utility, you mine the metadata to spot future patterns, which you commoditize to new components. Everybody screams, "You've eaten my business model," except for everybody else cheers because they can build new things more quickly, and you rinse and repeat. And very simply, you get everybody to appear to act as your almost like your free research and development department. You get everybody to innovate for you. You mine metadata to spot future patterns. You focus on commoditization. And the best way of doing this is with something called the press release process, which is a process whereby before anybody builds anything, they have to write the press release, because you can only write the press release for something which is known. You can't do it for something novel and new, so it forces everybody to focus on one side. The benefit of this system is that your apparent rate of innovation, customer focus, efficiency all increase now with the size of the ecosystem. The bigger that gets, the faster, more innovative, more customer focused you become. And simply what you do is you use this game to move up on the right-hand side of a map. So you just come out with compute, build a machine learning engine on top of it, machine learning platforms, you commoditize discrete AI services, etc. There are a couple of companies who are good at this, one in particular, and there's a couple of governments. Chinese government's very good at this. But if you want to read more about that, AWS launched its second ever book, Reaching Cloud Velocity. You'll find about 17 pages of mapping in there, including the whole ILC model. It's a fantastic way to tear up industry after industry. All right. So now I want to talk a little bit about symbols, because this is a map. This is a map paired back. You've got anchors, you've got components on here, you've got links. An important thing is you've got a date as well. You need a data map, because we don't have time on a map. We measure time through the transition. So this is a map in 2006. It's a map I can challenge. Again, why I've got custom built kettles, they should be more of a commodity. But even after we've challenged, components of the map may change over time. And so what you do is you measure time through differences in a map, and that's all. All right. On the map, we've got a compass, we've got visibility, and we've got evolution. We don't normally draw a compass on a map in that format. We normally just put the lines on the side. So we normally go value chain, which is basically our north and south, and east and west is our evolution at the bottom. And what we've got are components and needs. Now, these needs are a logical and. So your cup of tea needs cup, tea, and a hot water. Okay? But cup of tea is not the only solution here, because really what the public are after is refreshment. And if you're a tea shop, you're focused on providing refreshment to people. And there's, this will be a horror story for the Brits in the audience. There are more ways of refreshing people than just a cup of tea. A cup of tea is not the only solution to this problem. For example, we could have a cup of water. I know it's almost blasphemy in the UK. But anyway, we've got cup of water, which we've got cup, and we've got cold water. So what we've actually got here is a logical law. This is a choice that people can make. Same with power. There are many ways to do power. But anyway, so this is a logical choice. Now, normally we do it as an or statement. It could be an exclusive or. So I put another little symbol, little cross. You get to choose one. You can either have a cup of tea or you can have a cup of water. Most tea shops, you can have both. All right. Now, we also have constraints on a map. So, for example, tea isn't here, and that needs tea farms. And it might be the case that because of, I don't know, environmental change or something along those lines, there is a limitation or constraint in tea farms. So we often will, if there are particular components we want to highlight, there's a constraint on, we'll draw a thicker line. But at the same time, we can also do not only constraints, but we can do sort of negative constraints. So, for example, there might be tea-eating monsters. And those tea-eating monsters will have a negative effect on our tea. So you can think of that as the more tea-eating monsters there are, the less tea there will be. Okay. Now, another thing is I talked about visibility in the chain. So if you go from the point of view of the public through refreshment, through hot water kettle power's quite far removed. But if the public are concerned about a sustainable climate, that's another chain. And in that case, power is quite close to the actual consumer. So, for example, as a business, you might want to go, our tea is made with green energy. Now, of course, power, again, is an or statement. There are many different, you can have fossil, you can have renewable, you can have nuclear. We can expand that out quite easily. And, maybe we're lucky. Maybe a sustainable climate, is harmful for tea-eating monsters, which are harmful for tea. So we can put our assumptions not just in terms of ands and ors and XORs and nots and constraints and components and relationships. We can do these feedback loops. And of course, we can mark on that change is occurring. Maybe kettles aren't custom built. Maybe they're becoming more of a commodity. And of course, we have inertia to change because of pre-existing practices. And we can even have positive effects. So maybe as kettles become more of a commodity, if in our wonderful world where supposedly they're not, that may have a positive effect on sustainable climate. The point about this is maps aren't just about the nodes and the relationships between things. You can put a lot of logical context onto a map as well. And maps aren't limited to physical things. As I said, they're just labels at the bottom. And we use different labels when we're talking about practices, ethical values, even knowledge. And those are all systems you can map as well. Right. So what do I want to talk about symbols? Well, I want to introduce a bit of a problem. And I'm going to use some symbols to do this, which is basically how has AWS captured the future. And then we can use this to talk about the latest research. So when it comes to the future, Donald Rumsfeld talked about three things. There are the known knowns, known unknowns, unknown unknowns, i.e. the things we know, the things we know we don't know, and the things we don't know we don't know. I think that's great. But I also think he missed out the biggest group of all, which is the unknown knowns. The things that we don't know that we do know. And I think this is the biggest group. So, and I think those unknown knowns are these climatic patterns. And to show an example of why, I'm going to go back to that map in 2006 of compute. And compute was turning into a cloud. Amazon EC2, 2006. All right. Now, the axis at the bottom is evolution. It's not diffusion. And you mustn't mix those two up. And it's really important. And to explain why, that axis at the bottom came from this piece of work, which was looking at text analysis of publications that I did back in 2005, 2006. And it showed how you start off with something with early custom built examples, then you get early products, then you get maturing products and mature products, and then eventually it becomes a utility. And in fact, there could be hundreds of different instances. I've just put 5 here. There could be hundreds of different instances in the evolution of something. And we show that on a map like this. Okay, that's where that axis came from. The problem is each of these instances also diffuse. So if I take A1, A2, A3, A4, A5, I look at diffusion curves, they all go from 0 to 100% adoption in their applicable market. It's just the applicable markets are different and the time frames are different. But these are all diffusion curves, all with early adopters to laggards, and their own chasms. And so as something evolves, it can go through hundreds, if not thousands of diffusion curves and thousands of chasms. So why does that matter? Well, the red ones are product, and the purple one is the commodity. If I just go back, you can see I've just drawn it red going to commodity. So what you can often have is the majority on one diffusion curve and the minority on the more evolved diffusion curve. And so when you look at it in a map, it looks like this. You have the majority on compute as a product, and that's roughly where it was in 2010. So if you went around asking CIOs what's the future, they would tell you it's virtual data centers. They were going to own data centers, and they were going to use virtualization within data centers. They were going to own data centers. They were going to own the hardware. They were going to do their virtualization. And you talk about utility compute, and you talk about Amazon Cloud, and they would just, oh, that's for startups. Okay. Well, it wasn't for startups. What it meant was there were early adopters in that space, the majority on the less evolved form, and whether you like it or not, you are eventually going to have to go to that space. And of course, we saw the same with the practices. So there was the majority were about best architectural practices. There was this new thing called DevOps, which was built upon that utility cloud, and eventually that would evolve. DevOps, in this case, was not well evolved as a practice, but was evolving. By 2015, you started to see DevOps products. Now, underneath this, in terms of compute and cloud, there's a bit of shakiness. People are starting to go, well, actually, maybe cloud is not just for startups. Maybe big enterprises should be using cloud as well. Some had, very leading ones had already gone there. At the same time, exactly the same pattern with runtime. So we had .NET, LAMP, all this sort of stuff, and we had the serverless environment Lambda. And again, the majority were about their own runtime, managing that stack. That's why they focused on things like Kubernetes and containers. And the idea of using, that's just for startups. And you get that practice emerging. And of course, by 2020, now people are starting to have a real wobble about data centers. Really, data centers, no, the future is cloud now. You ask your CIO surveys these days, they'll tell you the future is cloud. In 2010, they tell you the future was virtualization in the data center. I think fundamentally it's changed. Just things have evolved more. They should have given the same answer. It was cloud in 2010. It was cloud in 2020. By 2025, you're going to probably see runtime, serverless. There'll be a bit of wobbling around there. By 2030, you start to discover that serverless dominates. Everything underneath it will start disappearing, which is where we should be thinking now. But of course, if you do a CIO survey and say, is the future serverless? It's Kubernetes. You're going to be wrong again. Okay. All I'm doing here is I'm applying a bunch of those climatic patterns. Everything evolves through supply and demand competition. Components can co-evolve with, so practice can co-evolve with activities. Evolution consists of multiple ways of diffusion. No choice over evolution, breed queen. Success breeds inertia. Okay, so that's 5 basic patterns. That's all I've done with those maps. As I said, there's about 30 on. Okay, we should all know this stuff. And I think those patterns are the unknowns. I think people are making decisions in environments they do not understand. They can't see the patterns. They have no maps. Okay, so they haven't learned this stuff. So they keep on making bad investment choices. So in 2020, it's pretty easy for me to say, best architectural practice, compute data centers, that's a liability. If you're not out of it, you should be doing everything you can be to get out of it. You should be exiting from runtime, from DevOps, from cloud, owning all of that stuff. You should be using serverless. You should be investing in FinOps. You can say that quite confidently in 2020, but you go to most organizations and they will tell you, no, that's not where they're going. They will be. So I thought, is this just an IT problem? Is it just a case of in IT, we don't understand these basic economic patterns? And therefore we keep on making these terrible investment choices. We keep on saying we're going to invest in, I don't know, big data, build our own data centers, build in private clouds, and then 10 years later go, oh, that was a mistake. Or do others do this as well? So I put together about 200 odd people, and we started to research into all these different areas: defense, finance, government, agriculture. And just to show you what it looks like, I'll take you to, let me have a look. Can you still see my screen? Somebody shout out.
Yes, we can, Simon.
Okay, so I've got 12 different research groups. And so we start out, and this is agriculture. So we start off by saying, okay, what matters in agriculture? And people come up with words. Vertical farming is really important. Food waste. Okay, disease prevention, baseline data. Within this group, there's a bunch of people from running companies in this space, to farmers, to people with different experiences. IoT is really important. LEO satellites, AI in agriculture, and all the rest of it. Great. All right. So which one really matters? Because I can get all these surveys of the future, and they farming surveys of the future tell me, AI is a really big thing. Robots and drones are going to be really huge. Okay, fine. Right. What do we base upon that? Just what other people are saying. So what I did was get them to start, first of all, categorizing. And they're doing this across all these different groups: defense, finance as well. So they first find a common meaning. And sometimes they create new meanings we want to explore. So like, what's the purpose of farming? Automation, misconceptions, carbon economy, digital twins, diet, bioeconomy, and regenerative farming, food waste, traceability. And then what we do is we take, there's two buckets here. Of the topics to examine, we move one topic across, like regenerative farming, and we start to explore it. We start to explore it using maps. So let me expand into this. So they start putting together a map. So what do we mean by this? When we're talking about regenerative farming, and they start talking about the components of it. But what's interesting is we've gone from generic memes, which you can just copy from others, to them exploring a space and actually challenging each other. These research groups, they're quite really ferocious discussions at points. Great fun. But they start thinking about the different components, and we've got various pipelines in here with various evolving components. And then they refine it, because then they disagree, and that's okay. And we can disagree. We disagree what's on a map. And eventually it starts to stabilize. So we're talking a lot in this map about farming practices, social knowledge, diversity of crops, the importance of the energy matrix, etc. And then they start to try to identify spaces on the map that actually matter. So this is where they get to. And this is just one area. And as I said, this stuff won't be published until the end of the year. So for all the things that matter, industrialization, conservation, should we be reducing support for monoculture? Should we be putting tax on synthetic? Should we be focused on climate change? Should we be focused on learning about regenerative farming at scale, certifications, maybe nationalization, co-op crowdfunding of particular spaces, maybe logistics? Of the four which came out that really mattered, it was education in terms of consumer behavior and labeling. Identity of farmers, because certainly in the UK and across Europe, the identity of farmers is actually quite weak as a group. They're often seen as a resource. And for that, we also need lobbying. And another area was our understanding of supply chains, because it turns out we atrociously understand our supply chains in the agricultural space. So we have all these wonderful sort of knock-on effects of various components further down the supply chain, which we don't see coming. And then we start comparing this to sort of like the research that's out there. And of course, all the research says the importance is all about industrialization, IoT, robotics, drones, gene editing, which is the stuff on the right. And then you start looking at the data, and this is one of my favorite graphs that comes out of this. This is cultivated hectares per agricultural worker and OECD countries. So what it basically means is the number of hectares a farmer can look after in an OECD country is about 25 to 30. So we have, industrialized so that we have very few farmers. But look at Asia. Asia has a lot more farmers per hectare. But if you look at plant production productivity, their plant production productivity is much higher per hectare. So they have more farmers per hectare and more productivity output. Whereas our systems, we have less farmers and we have less productivity per hectare. And of course, in the process of industrializing, we've basically created monocultures. So we've exposed ourselves also to huge amounts of risk. So the Asian system is not only more productive per hectare, it's also more resilient. Ours is less productive per hectare, more productive in terms of profit, because we have less people, we mechanize more, but also much, much more vulnerable to risks. And of course, at the moment, we've got various supply chain shocks regarding phosphorus, potassium, urea, so nitrogen, and our total dependence because our microbiological soil structure is so poor on these synthetic fertilizers. So, in the West, at points where we've got issues with potentially crop collapse and real food supply issues. I mean, we've got issues with rice imports, for example, with UK, with potato crops and obviously wheat. We hear about those, but we've got issues in terms of growing our own products as well. So that's one of the 12 research groups, and that's just one track within the 12 research groups. And what we're using MAPS for is to get away from this sort of generic what we do in IT, ask CIOs what the future is, ask experts what the future is. We're getting groups of people together to actually map out the space and use the maps to try to identify those areas we should be investing in based upon understanding of the landscape and how the patterns are changing, and then comparing that to reality. But as I said, that won't be available until the end of the year when we're ready to publish. At that point, I've taken up huge amounts of time. I hope you found that useful. I've got to say, I'm looking forward to this conference. Some really interesting talks, and hopefully that gives you an introduction into mapping. Just remember, all maps are imperfect representations for space. They're all maps. They're not graphs. There is a big difference there. And there are patterns that you can learn. And unfortunately for most of us, most of the industry doesn't seem to know this stuff at all. And at that point, I've got to find out how to stop sharing, because Hop-in has made that bit disappear for me.
Okay. We'll see. Maybe Holger can force take over your screen or something. We'll see.
Oh, please, yes, Holger, force take over my screen. Otherwise, you see this awful background, including my AI-generated picture. I got a AI to generate a future picture of myself. One of the fun things that I do.
Beautiful.
Thank you. Yes, Holger, you'll have to. Oh, hang on. What's this button here?
Yeah, it is a
Stop
button.
sharing. There we are.
There we go. Oh. Well done, Simon. Thank you so much for that introduction, both to mapping, of course, but also to the research that's going on.
Yeah.
I for sure have a number of questions, but I think the rest of the panel, do you have any questions that you would like to ask Simon? Anyone who has one can just speak out.
Shout at me.
Otherwise, I will just take over.
Well,
Joaquin.
I just I have a comment related to the last picture that Simon put on the screen related to the farm utilization and number of farmers.
Yeah.
That it's the graph for sure is not the same one in manufacturing, but the comments that you did were in certain areas of the manufacturing. Asia still has a lot of manual work.
Mm-hmm.
In reality, they are much flexible and are able to evolve this type of products quickly, that the Occidental world, that it's always focusing automation. And once that automation works, it's very, very difficult to promote change.
So the interesting thing, obviously I have a manufacturing group and a construction group, and as well as agriculture. So I just picked the agricultural track. We're finding some real shockers in the finance space again, lots to do with awareness. Also the defense space as well, some real shockers in that. So as we go through these, then we'll start bringing them together to see if there's some general overriding patterns, because some of them may be context specific to an industry, or there may be some general patterns that come out of this as well. So we're not quite there yet. That's why I wanted to show people, give an idea of the sort of stuff that we're doing with it. But 6 months' time, it'll be done. And then at that point, hopefully, we'll have enough evidence that we can say, look, this is why we think people are getting these investment choices wrong. Or it may be we come to a conclusion, actually, mapping was a really useful exercise in discussing this stuff. But, the actual tests that we do at the end don't demonstrate some sort of visible effect. So I certainly think it's an interesting point of discussion at this moment. Certainly within agriculture, certainly within education. Manish is smiling because we're having a lot of fun in the education group, and all the groups as well. But we can't drive a conclusion at the moment. So I just wanted, Holger asked me to show the sort of stuff that I'm doing. I wanted to show what I was doing, but we can't drive definitive conclusions out of this yet. Make sense?
Yeah, absolutely.
Perfect.
Yeah, makes sense to me.
Any other questions from the panel? If not, I have a few basic questions, not so advanced as your research project. So for me, when I started mapping and I did it with groups of people, I always had a bit of a challenge in challenging the map. Like, how do I go about it? How do I do it? So the way it would happen for me is that I've now seen so many maps that you've done or other people like Joaquin has done, and I feel like the ones we created, there's something wrong with them. Mm-hmm. And then, so some area feels wrong. But do you have sort of a practice or a way of thinking about challenging maps that the beginners can take with them?
Okay, so first of all maps are imperfect, even geographic maps. There's no such thing as a perfect map. A perfect map of France would be the size of France, so a 1-to-1 scale. And as a map, that would be useless. So all maps are imperfect. Rule number one. Rule number two, they're all models, so they're all wrong. So whenever you look at a map, the first thing you've got to think it's wrong and it's imperfect. Okay. Question is it useful? Because what it's really doing is we're exposing our assumptions about a space on the map in a way that you can look at the assumptions of others, which is very difficult to do in narrative story form. You can look at the assumptions of others and question and challenge. And so sometimes, I'll give an example in the research groups. As we're going along the research groups and we're putting these maps together, sometimes it's a case of, we're arguing about a component or the representation of a component. What do we mean by that? We use maps as well. We meet up once every 2 weeks for each group for an hour. And we use maps as a way of recapping the last meeting because it's super fast. You can just run through the map and you're back there where you were, rather than trying to do meeting notes because, I spent half an hour reading the meeting notes from a meeting 2 weeks ago and I still can't remember. Maps, I find, a really fast way of doing this. But what happens is the group will go, this doesn't feel right. This doesn't feel right. We'll argue about a component. And sometimes we'll sort of go, we're not happy with the perspective of the map. And so what we're not afraid to do is just to throw it away and start again. And so several times we do that. And sometimes we go, actually, bits that map was really useful. So all of the maps that we're producing are on GitHub. And we use online Wardley maps, so the code format from that. So you can go back and look at the version history. You can just go there, grab the code yourself, stick it on online Wardley maps, and play with it. But you should absolutely welcome people tearing it apart and changing it, because the important thing is to get to a group, a consensus between the group on what the space is, which is also why you need diversity of opinion in that group as well. So with the telecoms group, we had a lot of discussion because we've got a lot of people from the telecoms industry, and of course there's the satellite impacts. And so we particularly with the telecom industry, there's a whole issue to do with the fact that space is, just basically it's a commoditized version of the landscape. It's all the same. So when we talk about network topology is very custom built. When we talk about physical, as in landscapes, as in territory, because it's the home or wherever it happens to be, or it's a broadcast system. Whereas and it's only over a small range. Whereas space, it's Moore's law. Basically, it's just volume game. It's the more satellites you've got in low Earth orbit, the more bandwidth you've got, basically. And there is no topology. It's all identically the same. So it represents a commoditization of that space. And of course, that's quite a challenging thing if you're in the telecom industry and most of your value is from access to land and towers or whatever it happens to be. I see there have been more recently some sensible moves, like people like T-Mobile or others thinking, we can now see where the writing is on the wall. Lots of people are getting stuck in the sort of 5G direction, or trying to find physical reasons or constraints or laws why we're going to have fiber. I'm yet to come across them, though. But it's a fairly obvious change. But of course, if you're in that industry, it's quite difficult, which is why you create diverse groups, because you've got to have a bit of other experience in that.
Simon, I'm so sorry. I'm the
We've overrun. Sorry.
we have, I think it's 100 questions anymore, but the other speakers are waiting.
Oh, right. So I will shut up and go. Have fun. It looks fantastic. Apologies for overrunning and everything else. Lots of good questions. I'll hang around in one of the chat rooms and have fun. Enjoy yourself. Looks like it'll be fascinating.
We all will. Joaquin, will you take us out?
And thank you, Simon, for your time.
Yeah.
It's really amazing. Thank you.
Oh, well, I'm going to say thank you to everybody else, because everybody is volunteers in the research groups, which is fantastic. I've got to say thank you to the community for putting up with me, and my terrible habit of overrunning is much appreciated. It's an absolute pleasure. It's a delight.
Thank you so much. I am participating in the research group, and it's a very enriching process of 12 months, and it really encourages to read more and to look for other perspectives that it's really valuable, all the exercise.